All right, so in this section, we're going to talk about linear and exponential functions. Yesterday, I hinted at it a little bit, but basically, we're going to look at linear and their relationship to arithmetic, and we're going to look at exponential and its relationship to geometric because they're very similar. So we start with linear versus arithmetic sequences. So when we talk linear, we're talking about the left side of this box, right? Okay, when we talk linear, we're saying slope-intercept form of a line, which can either be written as like f of x equals mx plus b or y equals mx plus b, or the order can be switched and it could be b plus mx. The order there doesn't matter, right? When we look at an initial value in terms of a y-intercept, in terms of slope-intercept. Okay, so when we think about our initial value here, where do we typically start? If we're going to graph, let's say, where is our very first term? That y-intercept. So my initial value is going to be b. And then your rate of change is what? So I'm going to write them on both sides because the left side's rate of change, initial value, the right side is the constant rate of change. So that's slope. Now, if we think about it in terms of an arithmetic sequence, okay, our initial value, and notice that it says A0, okay, which would be like technically our initial term when I would, if you think about your homework from yesterday, if I took your AN equals A1 plus D times N minus 1, and you either distributed or you moved it back one to get your A0, we went to that from that format to this format, okay, which was how like you answered like 1, 2, 3, whatever was there. So on those, your initial value is what? A0. And your constant rate of change is what? D. So we can literally use these interchangeably. If it gives something information-wise in terms of arithmetic, I tend to choose to use it in terms of slope-intercept, okay? So we can go back and forth between arithmetic and slope-intercept to answer questions on both of those. The only difference, like we talked about yesterday, is what these things would look like on a graph, because arithmetic is going to be dots on a graph, and a slope-intercept would be a line. Then we compare exponential and geometric. So exponential is f of x equals a times b to the x. And geometric is a sub n equals, again, notice we're back to a0. So a0 r to the n. In both of these, you can look at coordinate points as either what you're plugging in for x and y on the exponential function, or as n and a sub n for a geometric sequence. So for example, if I said on an exponential function, you had 1, 3, and 2, 9. On a geometric sequence, you would be given a sub 1 equals 3 and a sub 2 equals 9. And these can be used interchangeably. Huh?
So A is like F of 2, A of 2.
Well, no, A is your rate. So A is what?
Yeah, but like comparably, like that's A of 2 instead of like F of X.
The bottom number, correct. Yep. All right, so this is the difference between them, okay? The domain of sequences versus exponential functions. And this is specifically for a geometric sequence and an exponential function. So on the left-hand side, you've got the dots. These dots would represent what? Geometric or exponential? Geometric. So this is going to be a geometric graph. And on the right, this is exponential. Same would happen if I'm talking about linear. The linear and arithmetic would be dots, and linear would be a line with arrows. So we can also compare those two, okay? Now, specifically when we're talking about the domain, when you're listing the domain in geometric arithmetic, you would answer them as 0, comma, 1, comma, 2, comma, 3, and so on and so forth. So the domain of this function that's graphed there would be 1, 2, 3, 4. We go all the way to, what is this? Actually, it's 0. Starts at 0, sorry. 0, 1, 2, 3, 4, 5, 6. So it would be 0, 1, 2, 3, 4, 5, 6. Whereas the domain of my exponential function, where it's cut off, so I assume those are arrows, would be all real numbers.
What is that thing next to the D?
Domain, it's just like a brace, like a squiggle.
Do you have to use it or can you use it?
Parentheses would imply interval notation, so it will usually do a braces. If it was an open-ended question, I don't know that I'd mark you off for that, but just know that that's how you'll see it, if it's multiple choice.
Is the right one too the same squiggle thing?
No, the right one is negative infinity, positive infinity, so it has to have the parentheses.
No, I'm saying like the right.
Yes. Okay, so then same thing would happen for my arithmetic. For this one, let's just say this was 1, 2, 3, 4, 5, 6. Then I would list it the same. 0, 1, 2. Oh, no, there's no 0 on that one. So it starts at 1. 1, 2, 3, 4, 5, 6. Whereas the linear function, my domain is going to be negative infinity to positive infinity. With me so far? All right, change in output values. So if we're talking about our change, then over equal length input value intervals, meaning I'm going from 0 to 1 and 1 to 2 and 2 to 3, or I'm going from 0 to 2 and 2 to 4 and 4 to 6, like same interval, okay? If the output values of a function change at a constant rate, which means the first difference is the same, then our function is linear. Nothing new there, okay? Here's what's new. If it changes proportionally, meaning I can divide these values and they would all be the same, then my function is exponential. So the first thing you're going to do is check your input values, make sure they go at the same interval, then look at your output values. If we're just classifying between linear or exponential, then all I'm doing is the first difference the same? That's linear. If not, is the second term divided by the first the same as the third divided by the second and the fourth divided by the third, and so on? So those questions will look something like this. A function has the following coordinate points. Could the function represent a linear, exponential function, or neither? So first thing we're doing is checking our intervals on the x values, making sure that they go by the same. Then I look at the output values and compare them. From 1 to 4 and 4 to 16, am I adding the same number each time? No, I'm multiplying the same number each time, which means these output values are proportional, and this is exponential. Now in exponential, it's f of x equals a times b to the x. So what would be the a on that one? It's like what your regular r is, right? Or sorry, not your a. What's your b on this one? Oh, okay, hang on. What are you multiplying by every time? 4, okay? Your initial value, you would have to know what 0 is. We don't have that on this one. But I do know that b would be 4. B is like your r when you're talking about geometric. It is like a b for exponential. Sorry, go ahead. Okay, now go to b. My input, check to make sure it's going by the same, and it is. Now I look at my output. What's true from 3 to 7 and 7 to 10? Are you adding the same thing? 7 minus 3 would be 4. 10 minus 7 would be 3. So not linear. Am I multiplying by the same thing? This would be 7 over 3 and 10 over 7. Those are not the same thing. So this is a neither scenario. And then the last one, it's going from 3 to 5 and 5 to 7. So not up by ones, but still consistent interval. So now I'm going from negative 1 to 7 and 7 to 15. Am I adding the same thing both times? Yes, because 7 minus a negative 1 and 15 minus 7 are both 8. So this is linear.
So you don't
And
know-
your M, sorry,
You don't know the second thing?
say again.
It's the second term. I'm so
The
confused.
input has to be by the same interval, but then you're looking at the output to determine if it's linear or exponential.
Okay.
And then what does that rate represent? Slope. So M in this case is 8. Actually, it's 4 because it's 8 over 2. So that one's tricky, right? Your interval went by 2s. So it's really 8 over 2. Yeah.
If it was the same x values, but it was -1,
You mean if this the same as this, so 3,
3,
5,
then
7.
2, 8, and 32.
Yeah.
That would be exponential, even
Correct.
though that it's not 1, 2, 3.
Right. No, it doesn't have to be 1. It just has to be consistent. Yep. Then we look at the bottom number. Then we look at the output. Okay. This would be the same too because you'll see it like this, and sometimes you'll see it like this, and it will say x, and it will say f of x, and it would be 3. Well, what's the first one? 2, 1, 2, 3, 4, 1, 4, 16. So they could either give it to you in coordinate point form or in a chart form, and you're looking for the same thing.
For like Austin, is it gonna go with the would the B or like R be 4, or would it be like,
It,
would you actually divide?
so I would take 2 points. I would plug them in as my big little, like we did yesterday. We're going to get to an example like that and figure out your R. Yep. So remember, we can't do it like we do slope because it's not the same. Yep. It's not constant.
Where'd you get the 2 from?
Which 2?
No, anyways.
Because we went by 2s, right? So your input values by 2. So if you're doing change in y over change in x to get slope, your change in y is 8. Your change in x is 2.
So the left side of each coordinate is on the bottom.
Right. Because it's just 2 coordinate points, right? It's 3, -1, and 5, 7. What's the slope of those two, of a line connecting those 2 points, right? 7 minus a -1 over 5 minus 3, which is 8 halves, which is 4. Yep. So honestly, when we go back and forth between linear and linear and arithmetic, I take all my stuff and I make it linear because we're way better at finding the slope of a line or finding slope intercept, right? But with exponential and geometric, if I get exponential points, I plug it into the geometric thing we did yesterday, which again, you'll see in a second. But if we're choosing, then I would go there. All right, so example 2, f of x is a linear function and it passes through 3, -1, and 7, 15. Write the equation for this function. So linear, we know we follow all the same rules we did in algebra 1. A linear function is y equals mx plus b. Or it's y minus y1 equals m times x minus x1. You get to choose. So for either of them, I need slope. I'm going to take my 2 points and make this x1, y1, x2, y2. 15 minus a -1 over 7 minus 3. And I get 16 over 4, which is 4 over 1, or 4. That's my slope. Now I can choose to either plug it into y equals mx plus b and solve for b and then plug back in the m and the b, or you can use point slope. Either way, I'm going to pick, you can pick either point. If there's a point that doesn't have a negative on it, I would highly recommend you grab that one because as smart as you guys are, negatives are like your kryptonites, okay? So I would do y minus y1, which I'm going to make this 7. I'm sorry, I'm going to make that 15 equals 4, which is my m, times x minus x1, which is 7. So y minus 15 equals 4x minus 28. Add the 15. And y equals 4x minus 13. You could also have done slope intercept, solve for b, and then plugged it back in. Questions so far? So if that had said an arithmetic function has the values of a(n), which would be a3 equals, what I give you, -1, and a7 equals 15, that entire question can be done the exact same way. I can convert that into coordinate points and find the equation using the slope-intercept form or the point slope. Okay, so now B says f of x is an exponential function that passes through 2, 1, and 4, 16. Write an equation for this function. So now B says f of x is an exponential function that passes through 2, 1, and 4, 16. Write an equation for this function. So when I approach exponential, like if I'm going between linear and arithmetic, I pick linear. We're way more comfortable with slope-intercept and point slope. But when you're between exponential and geometric, because you can switch those, right? Those are interchangeable. I pick geometric and I do the big little trick we did yesterday. So I'm going to take these two coordinate points, 2, 1, and 4, 16, and turn them into terms in my sequence. So it would be A2 equals 1, and it would be A4 equals 16. Now to find your R, I'm going to use the big little, which is A with the bigger base goes on the left, A with the smaller base goes on the right, and the R is raised to the power that is the difference between them. Now plug in what you know. A4 is what? 16. A2 is 1, R squared, so R squared equals 16. And R would technically equal plus or minus 16, right? But because we're talking about an exponential rate, we keep the positive, which is 4. With me so far? Okay, so now I'm going to show you how you can do this generically, and I'm going to show you how you would have to do it if it gave you a specific equation, because both could happen. So because it just says write the equation for the function, I could write this as any geometric equation like we did yesterday, where you can adjust your base and your exponential and your exponent for what you have. So because I have A2, I could say AN equals A2 times R to the N minus 2. Or I could say AN equals A4 times R to the N minus 4. And I'm going to plug in the A value that I have. And I'm going to plug in, this is A2. What I read there. A2, okay? I'm going to plug in what I have. So AN would equal, my A2 is 1 times R is 4 to the N minus 2. AN equals A4, which is 16, times R, which is 4, to the N minus 4. You with me so far? I'm almost there because technically these are in what format?
Geometric.
These are geometric. What's it asking you for? A function and exponential function form. So my A of n gets replaced with my f of x. And my n gets replaced with an x. So either of those answers would be fine if the question was worded as it is. Are we good so far? Okay, now what's going to happen on an FRQ is that it's going to say it is in the format of A0, it'll say A0, B to the X. Or no, actually we'll just say A, B to the X. And what this means is I need A0 in the spot where A is because X does not have anything after it, right? So it's X minus 0, which means it has to be A0. Well, I have A2 and I have A4. Excuse me. Thank you. How do I get to A0?
Backwards.
I got to go backwards. So if I have A2 is 1, how do I get to A1?
Divide by 4.
Divide by 4. Good, because my R is 4, right? Divide by 4, and I get A1 is 1/4. And then if I need to go to A0, I'm going to divide by 4 again. So what's A0? 1/16. So this is f of x equals 1/16 4 to the x. So for homework, it's not going to give you the format. You can answer it as we did the first two. But you'll see, and we'll practice it when we get to it. But eventually, you'll get to an FRQ where it gives you the format it has to be in, and you have to be able to adjust it. Questions? I honestly think that's the hardest part of the lesson. So if you can get that, good. Okay. All right, example 3 says the following functions are either linear or exponential. Identify the constant, slope, or ratio that causes the output values to change. So we're either finding the slope if it's your if it's linear, okay? And we're finding the R, or our rate of change, if it's exponential. So is A linear, exponential? It's linear. What would be your constant that causes the output values to change? Good. It's M, which is -2. Really, you just need -2. And B is linear, exponential? Exponential. So which one is the one that's the R? How do you know? Is it the order?
Yeah.
Because what if I did this? The one with the exponent. So this is 5. Okay, don't fall for that trap because they'll do that. Good on that question? Okay. Example 4 says determine whether the functions are linear or exponential. So remember when we had the coordinate points and I said you'll also see it like a T-chart? Here you go. So the first thing you're checking is what? Check the interval, good, on your input. So 3 to 7 and 7 to 11, is it the same?
Yeah.
Yes, you went by 4s. Okay, then I check first difference or proportion. So 6 minus 10 and 2 minus 6, are these the same? Yes, which means?
Linear.
Linear. And you could say first difference. Actually, no, the wording is as the input values increase, the output values increase at a constant rate. Decrease, thank you, decrease at a constant rate.
You don't have to put about how much is increasing or decreasing.
No, because that, it doesn't matter how much when you're determining if it's linear, as long as it is, right? If it's a describe the rate of change, now that's different. Like, and what does it mean in this context? We'll give you some kind of context. Like it would say x represents this and f of x represents this. Okay, now go to B. Are the intervals on my input the same? Yes. What's true about the outputs? 6 minus 2 does not equal 18 minus 6, right? So it's not linear. Does 6 over 2 equal 18 over 6? Yes, they're both 3, right? So these are exponential. And we say as the input values increase, the output values are proportional. So let's say this gets thrown in with class of, because let's say it's a multiple choice question, or let's say it's on FRQ where it starts to bring everything together. And you get this function and it says classify it as linear, quadratic, cubic, or exponential. We're going to look at the first difference. First difference is same linear. Second difference is same quadratic. Third difference is same cubic. None of those, and your outputs are proportional. Now it's exponential. Does that make sense? We'll eventually get to one more, which is logs, but those are the 4 really we've looked at for now. Yeah.
The difference between exponential and quadratic is second difference, and exponential is
That you're multiplying by the same thing each time. Yep. So quadratic has an exponent, but the exponent is 2. Exponential, your exponent is changing because that's your input. Okay, last question. For an arithmetic sequence, Sn, S of 2 equals 10 and S of 5 equals 22. What's the value of S of 12 minus S of 9? So there's a couple different ways to do this. But first of all, you're not allowed to freak out when you see arithmetic because arithmetic is really just linear. Same as linear, okay? Obviously, but not the decimals in between. So if I have S of 2 equals 10 and I have S of 5 equals 22, I could change this to what? Good. 210 and 522. Now, with those 2 coordinate points, I could make an equation that could tell you any point on this line, right? Or any point, any data point on this sequence. So I could say my slope is 22 minus 10 over 5 minus 2, which is 12 over 3, which is 4. Slope is 4. And then I could pick either point, plug it into point slope or plug it into slope intercept. So I'm going to use 210. Y minus 10 equals 4 times x minus 2. Y minus 10 equals 4x minus 8. Add the 10. And y equals 4x plus 2. That equation is going to get me any of the terms in this sequence. Which two terms do I want? The 12th one and the 9th one. So I'm going to plug in 12. Y equals 4 times 12 plus 2. 48 plus 2 is 50. And I'm going to plug in 9. 4 times 9 plus 2. 36 plus 2, which is 38. So what's the value of S of 12 minus S of 9? 12. Good. You also could get your rate of change, figure out how many jumps there are here, right? And multiply that by the number of jumps. So there's a lot of different ways to do this. But if it initially had said find S of 9 and S of 12, now you got to find it that way. Yeah.
So what you're saying for like the rate of change, because we can see that it jumps like 3 times.
Right. It's going from 9 to 10, 10 to 11, 11 to 12. That's 3 jumps. And each time it jumps 4 times. I mean, yeah. Each time it jumps 4, not 4 times, 4. Does that make sense?
Yeah.
Okay. But just pay attention to how it asks you, because it might say, like, if this has multiple parts, it might say find S of, we'll find the equation to find a term in this. Find S of 9 and S of 12. Find S of 12 minus S of 9. Now you got to find it that way.
We could only do that for arithmetic, right?
The jump, correct. You'd have to multiply it each time for the other one. It doesn't work. Yeah. So you can't do it won't be a minus. It would be a divided by. And then it'd be 3 times. Yeah, which I think is probably easier to do it the other way. Questions on anything related to 2-2? Okay.